Hey there, everybody. This is Glenn checking in with you, and today we have an action-packed agenda for you. We're going to be taking a look at some of the wall details that Schindler typically used in some of his houses, and really look at some specific examples of how they're applied. He had sort of a very standard wall framing system that he was advocating, and there's some really particularly interesting things about it that we'll go ahead and teach you how to model accurately within Revit, and then hopefully we can go ahead and extend this to some of the other different types of walls that you're using for the other houses. To get started, let's go ahead and just take a look at the basic wall system that Schindler proposed. Let me go ahead and bring up an example. This is what he called the Schindler frame, and let me pull it out a little bit. This is actually something that's on the Dropbox folder, and it's an incredibly densely packed drawing. There's a lot of information in here. But if you scroll on in, zoom on in, and kind of start taking a look at it, you'll see really an indication of a standard wall system. He's specking out a lot of information in here for a lot of different cases. That's what sort of makes the drawing kind of challenging to take a look at, because we're looking at sort of an exterior wall case and the foundation treatment over like treated wood. We're looking at it in terms of just a framed floor over like just the concrete and the precast concrete beams that we looked at in some of the last sessions. And we're looking at just different conditions, kind of a straight up condition where we have like a wood wall over a plaster wall. We're looking at some clear story conditions, but there's a lot of stuff in here indicating, just the section conditions and the elevation conditions for the windows, the door frames, just an awful lot of information in here, but we'll kind of unpack that a little bit at a time. Down at the bottom of this drawing, there are actually a lot of details kind of showing all the specifics of the door framing, both in kind of section view and plan view, the window framing, a lot of detail all about how those window and wall connections are going to work. Because that's actually where a lot of the detail is. Once you get the basic wall system down, a lot of it just comes down to the connections between the openings and the wall system framing. Okay, another example you can go ahead and take a look at is, let's pop this up. It's the Jansen house. Okay, and this is just an example of actually that Schindler system being used in place. So you see in this drawing a lot of the same sort of details just kind of called out specifically for how it was going to be implemented here. Where there's things like we have the basic wall system. There's that little funny detail in the corner where we're going through and putting a little kind of triangular base in there. This is kind of the clear story condition with a wooden wall, the transom window, a little bit of beam underneath it, and some planking over here forming a little bit of a ceiling. Just kind of the clear storing area. Yeah, same sort of basic foundation condition. So this is just an example of it actually carried out. And this is kind of a typical way he worked, sort of dictating the overall system and then specking out the specific differences on the individual houses. So let's go ahead and take a look at that one first. We're later going to go ahead and take a look at the issue of the King's Road house, which actually has a very different sort of wall system, a lot of precast kind of concrete elements, but we'll save that one for a little bit later in the session. So let's get started on this one. So switching back to Revit, let's go ahead and get started by modeling just some of those foundation elements, and then we'll start building the walls on top of them. Now for what we're going to do, I'll just go ahead and build kind of a standard little foundation, kind of a prototype. It won't really be specific to any of the houses, and that's going to be okay for what we're doing getting started. Let's start by just putting just a little bit of site down for ourselves. Let me go ahead and close that up and actually switch to the site plan view. That would be a better thing to do because the site will be visible there. And in terms of putting this down, if we go back and look at the detail, you'll actually see, I'm switching back over there to the standard one, that typically when he went through and did these, we would always have the site or the subfloor, which is going to be level 1 within our building. We'll go ahead and have the subfloor at least 6 inches above the grade. That's typically just to allow for kind of a water kind of detail so we don't get water into the building. We like to basically allow that the finished floor is up above where the grade finishes off. So let's go through and start with that. If we go through and put the topology at about -6 inches, we'll just do that as a starting point as opposed to a detailed topology. I'll just put -6 inches in here. And I'm just going to sort of put a big old site down and not really worry about it too much because we're just really using it as a base. Okay. Let's go ahead and straighten that out. Okay, and we'll finish that up. Okay, we have our basic site down now. Now we can go through and actually start thinking about putting in some foundation walls, and then on top of those, or underneath those foundation walls, we'll go ahead and cut out a building pad. So let's get going with that. That's sort of something we looked at last time, where we'll go over to the Home tab, and we'll switch to the walls, and we'll say, let's go ahead and get some sort of foundation wall type, and we can go ahead and create like any type we want. Oh, I'm trying to remember what we did last time. It was about 6 inches or 8 inches. Let me make a 6-inch foundation wall. We'll edit this type, and I'll duplicate this, saying we'll just do a 6-inch wall. We'll edit the structure so that it's the 6 inches of cast-in-place concrete. Okay. Then we'll go through, and once the type is created, start thinking about the properties that we're going to be putting in here. And what we want to think about is the top and bottom of that wall, okay, relative to the level 1, and let's think about that. If we go back over to the detail, we'll see that that foundation wall, if we count the planking, which is going to be the subfloor, and that's what we're going to use at the top of level 1, which is minus 1.5 inches, inch and a half for the base plate there. It's going to be about 3 inches down. So the top of our foundation wall is going to be about 3 inches below level 1. Below that is really just however deep we're going to go, maybe 2 feet deep, something like that. So if I switch back over to Revit, what that'll look like is for the top constraint, let's go ahead and bring that to top is level 1 minus, and I'll put an offset in here. That's kind of the easiest way to do it, minus 3 inches. Okay. Down here at the bottom, we'll go through and say, oh, that's level 1 minus like 2 feet, just whatever it's going to be for our specific soil conditions. We can apply all that. That's just going to sort of be the standard for right now. And we can then just put in some sort of a foundation. Again, I'm not going to worry about this too much because this is going to be a little bit of a prototype for doing the different wall systems. Okay. We got that in place. Let's go ahead and take a look at that in 3D just to make sure it's looking good. Oh, what can I do? Let me put it in wireframe so we can sort of see. That's not too bad. I will shade it again. Okay, what's happening here right now is you see it's poking up a little bit outside the dirt. We still have to kind of put a building pad in here. So let's go ahead and do that and actually put the strip footing underneath it too. For the, I'll go back to the wireframe so I can sort of see the little strip footing going in there. For the strip footing, let's go through and do that just using the foundation elements that we talked about last time. We'll say let's go through and put a wall foundation in there. And then for that, oh, what was his detail again? It was something like, oh, if it's 6 inches, I think it's about 12 inches wide by about 6 inches deep. He used a relatively small foundation. So what we can do is duplicate this type. And I'll say that I'm going to make something that's 12 inches wide by about 6 inches deep. And again, we can change that later as needed, just to sort of fit the specific conditions. So about 0.6 on the foundation thickness. Say OK to that. And now we can just go ahead and start choosing these walls. So we can choose all 4 of those walls. Shade that if we want to. The eccentricity is something interesting. That would be if it's not centered on the wall. If we wanted to have it kind of kicked out to the outside or kicked to the inside, we can sort of enter a little bit of offset in there. But we'll go ahead and leave it like this. And the final thing we're going to do just to kind of get ready for this is actually just put in the building pad itself. So let's talk about that. For the building pad, let's go ahead and put something that's, oh, if we look at his detail, okay, what is it going to be? We have basically, oh, the floor level here. That's going to be level 1. We want the 6 inches. We want to go down even further still. And I don't think he calls out something specific. Typically, well, looks like he's showing about a foot over there. So maybe about 18 inches, something like that. So let's go ahead and put it either 18 inches or 2 feet below the floor level, something like that. Let's go back over to Revit and do that. So what I'll do is go back to the first floor plan. Actually, it's interesting. Why can I cannot see those things right now just because the foundation is below that first floor level. Let me go ahead and change that so we can see that first floor foundation. In fact, I think Mary Lou mentioned that someone had this problem as they were working. The problem is the foundation is below the floor level and the view range is set to cut off at level 1. What we need to do is just sort of extend it so we can see a little bit further. So let me say either level below or unlimited, or I can even just sort of put an offset in here, maybe 2 feet down. And what that'll do is just make it visible so we can actually see it. Okay, and that's kind of a classic problem as you're working with foundations, is that they're often below your floor level, so you have to kind of worry about like just changing your view range so you can actually see them within the level or see them underlaid under the level. Okay, so to put the building pad in, again, we'll go back to the Site tab. We'll choose the building pad. We can sort of choose a specific type if we want to. Let's kind of edit the type in here. For this, we have something that's like 1 inch thick. Let me go ahead and just put like a little earth layer or something like that, because I don't really want to have much in there besides suppressing the earth. I'll make it about, 1 inch thick or something like that. I can even choose a property for it. Maybe I'll just call it earth. Again, all I'm really doing is suppressing. I have to give it something. I could even make it like a 1/16 of an inch thick or something like that. Just has to have a little bit of thickness to it. And we'll say OK to that. And then in terms of where to place it, relative to level 1, let me go ahead and place it at, say, minus 18 inches. Then to draw it, I'll pick the walls. Let me zoom out a little bit so I can actually pick the outside surface of the walls. That way it'll cut away the area that includes the concrete wall. We'll finish that up. And hopefully now, as we go ahead and take a look at this all in 3D, let me shade it again. Yeah, we'll have something that actually looks like a little bit of a suppressed earth. Beautiful. Okay, let's pause there for just a second. Okay, let's go ahead and also consider that other case, not just the exterior foundation, because Schindler had a detail for that too. It's that case where we have that precast concrete beam, something about 6 inches by 8 inches, something like that. So let's go ahead and kind of put one of those in there too, just so we can illustrate that case. If I switch myself back over to Revit, let's go back to structure, and I will put in a beam. Okay, now for that beam, this is the standard like a wide flange steel beam. What I want to do is load in a concrete one instead. So I can go down to the structure, look inside framing, find concrete, and find a rectangular beam type. It won't be the right size, but I'll at least get us started. And then what we do is edit that type and duplicate it. We want to create something relatively small, like 8 inches tall by 6 inches wide or something like that. So maybe 6 inches by 8 inches. We'll say OK to that. And then we'll change the actual dimensions here, 0'6" by 0'8". Put that in. And then in terms of where we're going to go through and put that, we can go ahead and put it at level 1. Okay, but what I want to do is actually offset it down a little bit. And what I want to do is actually offset it down to be, not only the thickness of the planking, okay, but also the thickness of the little base plate here. So it's about minus 3 inches. So what I'll do is, in that same sense, I'm just going to lower this by saying that the top of it should be minus 3 inches. That'll hopefully put it at right about the same height as the top of the concrete. Okay, so I can now go through and put in one of these beams. Maybe I'll put it across this way. Now, it wouldn't actually span the entire distance here. We'd have to have some intermediate girders, but I'll at least put one in there. Okay, maybe we can put some other ones in there, just as many as we need. So put another one in here, somewhere over here. Again, I'm not being at all precise about the location of these things because I'm just using them as illustrations. Put that one in there. Okay, we have some nice concrete beams. Super. So we're actually looking pretty good right now. Let's go ahead and just cut a section just to sort of see how we're doing from that perspective. What I'll do is go switch to the View tab, and I'll use the Section tool. Let's cut one in this direction. Okay, and let's take a look at what that looks like. So you can sort of see we're not looking all that dissimilar right now from the detail. You can turn that up a little bit if we want to see a little more detail. Didn't really change much, did it? Okay, but we have the beam in here, we have the footing, we have all those sorts of things. We can join some of the things together. For example, if we want to sort of see that footing detail closer to this, what we can do is come over and, I think I have to choose one first. And I can say join. Let me join this piece to that piece. Okay, that'll clean that up a little bit. But we'll do some more things to kind of clean up the details a little bit. The important thing to note here is just that relative, let me go ahead and join this one too, since we're going to be looking at that. Choose that. Modify, join this one to that one. Okay, we're going to be adding a little bit more to this because the top of our floor is actually going to be up at this level. And even to sort of clarify this a little bit, what may be helpful is to actually switch to a thin line mode. Thin line mode, again, is all about this notion that in the standard mode, which is showing the default line widths, it sometimes gets a little bit hard to kind of see what's going on because the line width just obscures the dimensions of the geometry. At 1/8 inch scale, that'd be especially true. Let me pop this up to 1/4 inch scale. Or I could even go ahead and pop that up to a higher scale, like 1/2 inch scale or something like that, where the line widths wouldn't be so dominant in the view. Okay, maybe that's not too bad looking, but we can make that thin widths or like fat lines, depending on what you want. Okay, let's go ahead, and the next step we're going to do is actually start modeling in the whole notion of the base plates. So let's talk about that. Okay, now the base plate is actually something, if I'm being perfectly honest, a lot of folks probably wouldn't even bother modeling at this point in the process. I'll go ahead and show you how to do it, but a lot of people would skip this and just going to do it as part of a detail later. Because we're going to get to this whole issue of really, as we're modeling things, do you model every last stick of wood, or do you only model kind of those as detail items and kind of or in typical details? Do you actually have to model every stick? And you really don't want to model every stick, but for the sake of being polite here, I'll go ahead and show you how we would model that base plate, but this might be a step that you can skip and just add in as a detail. It could go either way on that one. But if I was going to go ahead and model that, here's what I'd want to do. I basically want to think about that base plate, and if I go back over to the detail and we take a look at it, it's pretty much a 2x4 laid flat is what we call it. So 3.5 wide by about 1.5 inches tall by today's standards, a little bit bigger when the house was actually built. But if we were going ahead and model that, I'd probably take a profile and sweep it around. That'd be the easiest way. I could model as a bunch of individual sticks, like individual beams, and put them on top there, but that might be even a little bit more work. So I'm going to just do it as a profile, because I think a swept profile, I think that might be the easiest way to kind of get a quick approximation. So if I pop back over to Revit again, here's what we might do. Okay, we're going to basically do a sweep. It's called an in-place sweep because we're going to follow some existing geometry. Okay, and what we're going to do is actually just develop a profile. And in terms of that profile, I can sort of be sneaky about this. I just need a rectangular box that's like 3.5 wide by 1.5 tall. And I could create one that's specifically for that. I don't think there is one. Can I just take a look and see if there is? I don't think there is. Let me insert, load family. I can go down to profiles and see if one exists. What do I have in here? Maybe I have one structural, slab edge, wide flange. No, I don't actually have kind of one that's just a rectangular piece. Let's see if I have anything in here. Not seeing one right offhand, so we're going to go ahead and create one. And we'll do it just kind of in a tricky way because there's actually one that we can use that's pretty close to what we need. If you go into the existing families and you just go down into profiles, you'll actually find that there is something nice and rectangular. It's just a handrail piece. Okay, and if we grab that thing, let me go ahead and just edit its family. What I'm going to do is actually choose the family, not the instant or the type, but the family, and I'll edit it. You'll see it's just a big old rectangular piece, and we can change the size of it. Let me do a save as, because what I'm going to go ahead and just call this, as opposed to being the rectangular piece or the rectangular handrail, I'm just going to go through and call this, and I'll put it in my documents right now, but we can put it anywhere in your library. Let's go ahead and call this, this will be like just dimensional lumber. Okay, and that's really just more for our convenience to sort of think about it so it shows up looking right. I'm going to load it with that name back into our project. And here's what we're going to do. In those profiles, I'm going to find dimensional lumber right now. Let me just open one of the existing types, and I'll duplicate it, because what I want to do is just create something that's basically 3.5 inches by 1.5 inches. Again, that's just a name. So I can say it's going to be 3.5 by 1.5. Oops. Great. And now we have one to work with, and we can start sweeping it. Okay. So how do we sweep it? Let's go back out to maybe the 3D view. That might be a little bit easier. here's what we're going to do. We're going to go through and create something called an in-place component. We're going to do a lot of different types of components. We've probably already put some indoors and windows components. This is an example of something where we're creating something custom to our geometry, where I'll say place or model in place. You have to always sort of choose what type of thing you're creating, and I call it structural framing because that's actually what it is. It needs to be kind of classified in the right kind of order of things so that it'll appear or disappear and be handled properly in terms of all the viewing. I'm going to call this just my base plates. And then what is it? It's a sweep. There's extrusions, blends, revolves, and sweeps. We'll talk more about this in a lot more detail in a couple weeks. Let's just do the sweep. I think if you're familiar with a lot of geometric and form modeling, you've probably seen these before. I can first choose the path. I'll pick a path. And what I can do is actually, let me see, even pick 3D edges. See if I can get that. I want that edge on the outside there, that edge over there. So I'm picking the outside edges. See if I can get that edge over on this side too. So if that is my path, let me go ahead and close that. Oh, it says that it doesn't want me to go ahead and do that because it only allows sort of a single loop. What I have to do is a little bit of a, what I call it, just extending or trimming to make this work. Let me see if I can make that happen. What I want to do is just trim this one to that one. I have my pink line rules, so I need to go through and just get those things closed up so that it's considered a single path. So I'm trimming to bring those things together. Okay, now I can close that up. Beautiful. Next thing we're going to do is actually just edit the profile or load the profile. I could draw a profile. In fact, I could have just drawn something 1.5 by 3.5. Since I created one, let me go ahead and load it already. I'll load a profile. Oh, hang on. I think I might be able to even do it here. There it is, dimensional lumber. Since it's already loaded in, we loaded it into the project. All I have to do is choose it. Let me choose the 3.5 by 1.5. Okay. Zoom on in there. You can sort of see, oh, there's a little bit of a notion of how it's placed relative to that line. Okay. What I'm going to do is just do a little shifting over. In the X direction, I'm going to shift it over, let me try 1 3/4. That's half of 3.5. That's how I'm getting that number. Because it looks like it's centered on it right now. Now it looks like it pulled it completely to the outside. Let me shift it the other way. Minus 1 3/4. Okay, now it's on the inside. And now we'll try bringing it up, 0, 1.5. Okay, and that's actually looking pretty good now. So what'll happen now is if I go through and choose this, and I say finish it, okay, it's actually sort of created a 3D element going all the way around there that hopefully is in the right place. We can take a look at it in the section view just to confirm that it is. There it is. Okay, and again, this is sort of an example of something that I probably wouldn't necessarily model. I'm sorry if that looked like a lot of work, but I just wanted to show you what the technique was for how you can go ahead and create that. But that's how you can go ahead and create this base plate if you want to actually model it in 3D. Okay, one final step I neglected to do. Let me go ahead and click Finish Model. That'll actually finish creating the object. The idea is for those in-place objects, we can go through and just kind of keep on adding pieces, make objects that are actually made up out of more than a single form. So that's what that would be all about. Now, I told you that we don't typically model them that way. Let's talk about what we typically do in terms of like doing something like that. And that is when it's time to go ahead and create a section like this or create a detail like this, what we often do is if you don't want to model every last piece of it, is you go through and just add detail items, which are really just line work on top of something like this. So for example, if I go over here to the detail, you'll see there's an anchor bolt, there's this little cross symbol which indicates that it's actually the base plate. That's just how we look at dimensional lumber when it's kind of cut in section. And if you want to go through and illustrate something like that, it looks like this. What you do is you go to the Annotate tab, okay, and we can add line work. I could actually draw line work and sort of put in detail lines to sort of just, draft that very much like we do in AutoCAD or any other system. But there's also components which are drafting components, and we can put in some of those. Let me show you what that would look like. So we'll go back to Annotate, and we can choose Component, and let's see what we have available. Well, looks like a big old beam component. That's actually not a true beam. That's just a piece of line work that looks like that. There's some brick. Let me load in an anchor bolt and load in some dimensional lumber just so you can see what that would look like. So what will happen in end of the library under detail components, you'll find, let me find wood and plastic, wood framing, nominal cut lumber in section, which looks like this. I could bring in a lot of different sizes and stuff like that, but let me go ahead and just bring in 2x4, 2x6, 8, 10, maybe even 12. I'm control clicking to get a bunch of them. That's just getting a bunch of different sizes that'll be available to us. So here we have the 2x4. This is just a piece of line work, but I can tab to rotate it over and then go dropping it on. And that'll just make our section, our details in our sections look a little bit better. Again, has no effect on the 3D model, but in this 2D view, it'll look a little better. Same sort of thing, let me go ahead and put in a detail component for that anchor bolt. I'll load the family. I've got to find it all the time. It's detail components. I think it's under, like metals. And there's some sort of common connectors. Let's see if it's in there. The bolts are in there. There's anchor bolts. Looking at it from the top or looking at it from the side. Again, just a piece of 2D line work, but it's better than having to draw it out manually. Now this looks a little bit strange. 1.5" anchor bolt. Let's see if we have a different type available. That looks a little bit big. Maybe like a 1/2 inch or a 5/8 inch, probably what he used. That's a little nicer looking. And now I can go through and put it in there. Okay. Again, since it's a component, you can do groovy things like, just change the length if it turns out it's a foot long. Didn't stretch very nicely. Okay, but create a nice looking detail like that. And again, looks good in 2D, good for creating the construction documents out of your BIM model. Okay, but that's just kind of a nice thing to do to kind of get yourself going. Okay, next thing we want to do is actually create the floor systems themselves. So let's move on to that one. Okay, now creating the floor systems themselves is actually pretty easy to do because we're going to create a standard floor. We're going to pay a little attention to the layering in the floors and how we place it, but floors, again, go pretty easily. Let's take a look at that. I'll go to the Home tab, and I'll choose the Floor tool. And here's the deal. We'll choose just a regular old floor as a starting point. I'm going to have to say where we're going to put it. I'm going to put it on floor plan level 1. It doesn't like to draw floors in the section view. That's what it's complaining about right now. So let me switch on over. Okay, what we'll do is we have the generic 12-inch floor, and if we were kind of at a very coarse level of modeling and not caring about the construction, we can use that one. Or we can go ahead and create our own floor type that actually sort of models things accurately. If we look at actually his floors, let's go back to Schindler's details. There's a couple of floors we'll look at. One is this issue of there's like a 1.5-inch plank over some treated wood. Okay, that's one of his standard conditions. The other one's just sort of an 1.5-inch plank. We're going to ignore that finished floor for now. We're going to add that a little bit later. Typically when we do this, we sort of work to the top of the subfloor, which is that plank floor. So let me switch back over. And what we will do is create something like that. And let's take a look and see if we have something that's similar. We have some multi-layer floors here. Maybe I'll use one of those as a starting point because it's, we're just going to be doing a little bit of adjusting. Let me choose that one as a starting point. And we will duplicate it, edit it, and duplicate it. And what I want to basically say is that I have, a 1.5-inch plank. Let's say over 2x6 framing. Okay, and it can be different. We're going to create as many different types as we need to. To actually show that structure, what I would say is I'll edit it, and what do I want to have? I'm going to leave out the finished floor for right now. We'll put that in a little bit later. For the actual structure of the floor, it's going to be, let's call it, I could call it wood sheathing. We'll give it a different layer in a second here. Let's call it 1.5 inches in there. Okay, and then for the structural wood layer, let's call that, that's for 2x6s, it'd be 5.5 inches, so 0, 5.5. Now, if we would like that wood layer, that wood planking to look a little bit better, let's go ahead and take a look at how we could do that. Because if we wanted to have sort of an appearance, like if you look at Schindler's appearance, he has this kind of wavy finished line or finished lumber sort of look. We can go to the materials and create something. Because wood sheathing, okay, currently doesn't have some sort of surface pattern to it. We can create a different material for our finished lumber. In fact, I think it even has one in here. That's his flooring. We'll use that for the finished flooring in a little bit. Let me dupe this, and I'll create one, call this wood floor planking. Okay, and I'm just creating a new material to work with. And the reason I'm doing this is I really just want to have sort of a different surface pattern, so when it's cut, or it's kind of looking on the surface, either way, we can go ahead and have an appearance. Like the surface pattern, 3 inches parallel, that may be about right. It's kind of the thickness of the boards if we were looking at it like in a plan view, something like that. For the cut pattern, oh, it's currently showing this diagonal down. Let's see if I can find something that looks a little bit better. Like we could go for like, oh, this wavy wood pattern. That might be nice in black. We'll put that in there, and now what I need to do is just shift this over so this is pointing to. It looks like I did. Wood planking. We'll say okay to all that, and I think this is going to look pretty good. Dimensional, about 5.5 inches. That looks pretty good. Let's go ahead and draw some and see how it actually looks when we put it together. So what I am going to do is I'll put it over part of the building. I will say that we're going to choose some walls. Pick those. Let me go through and, what do I want? Because I'm going to use the foundation walls as the boundary. For the level, this is where we get to think about what the top of the subfloor, where it'll be, and it will be right at level 1, so that height is actually looking good. Let me pick this wall. I'll pick this wall, and on the back side, just so I can go ahead and put 2 different systems in here, I'm just going to close it off with more of a line back there, and we'll join it from the other side. Let me trim this floor. So I just have it over half the building. I'll close that up. Let's talk about that. This is sort of an interesting question. This is this whole issue of should the walls attach to the bottom? Typically, that's often a good choice. I'm going to say no to this right now because actually I don't want the foundation wall to kind of jump up and kind of get cut off by the bottom of the floor. They actually sort of overlap in an interesting way. So I'm going to say no. You know, often that answer would be yes. Like when we're doing frame walls and we want them to come up to a roof or come up to a floor, like a second floor level. But I don't want it to happen here, so I'm going to say no. Then there's this whole issue of this overlapping volume. And that I'm going to say yes to, and I'll show you what the effect is in just a second here. Say yes. And let's take a look at it in section and see what that actually did. Actually, it's interesting. That was sort of a bad choice because it did what I didn't want it to do. I'm going to go back and undo that. And because what it's doing is it's basically trying to say these 2 walls are intersecting with each other. The framing is coming over and intersecting with the concrete, and it's taking away some of that volume. And that's actually not what I wanted to do. Often that is what you want it to do when you're doing a second floor framing into like a first floor walls, but that wasn't what I wanted here. So let me just do an undo. Okay, and there we have it back to here. We can go ahead and clean this up. We'll talk about detailing and how we can kind of clean this up a little bit later. Okay, in terms of removing that line and making this detail look a little bit better. But for right now, let's just leave it at that out of the interest of time. Okay, looking pretty good in terms of this side. Let's go through and create something for the other half of the foundation, where I just have that planking and I want it to go over these beams and stuff like that. So what that would be is, let's go back to the floor again. Oh, let me go ahead and save the project. I'll actually do, let's say, Schindler wall type examples. I'm going to switch back over to level 1 for drawing this. Okay, for the other floor, let me finish this. Sketch is empty. Oh, looks like I'm halfway through doing something. Well, let's quit sketching. Okay, let's go back. Oh, no, I'd already started the floor. Oh, pardon me, I'm confused. We'll say floor. We're going to edit this type because the other type is very similar. It's just going to be the planking, though. It's not going to have the wood framing underneath it. So I'm just going to duplicate this, and I'll say just a 1.5 inch plank. Then for the structure, we'll just take out the structural framing underneath it. Okay, and that'll just be 1.5 inches thick. Say okay to that. For this one, again, we'll go through and pick some walls. Maybe on the outside here. on the outside here. On this inside, let me just pick the edge of that. That's actually kind of a nice thing to do. If I'm going to trim this up. The reason it's nice to pick the edges is if that boundary ever moves, the new floor boundary will follow the edge of the other floor, if that makes sense. Let me say finish this up. Okay, and let's take a look at that in section. And I think we should be in pretty good shape. Yep. So we're in pretty good shape on this side too. If I really want to go ahead and complete this, I can put the detail items in here, put the anchor bolt in there, and over these precast beams, I could decide either I could model those like base plates here, or I could just sort of draw them in as details. Either way, because what you're trying to do is get something that looks like this. Okay, so take your pick. Just depends on how much level you want to get to in terms of modeling every last detail. Okay. I think we have our floors in place, so the next thing we're going to turn our attention to is actually just creating the wall types that we need to put in there. So let me go ahead and pause for a second, and we'll pick that up. Okay, so for creating our wall systems, let's go ahead and just take a look at the standard details that Schindler put together and see if we can kind of come up with just some standard cases that we're going to try to model. One case, probably the most standard case of the house, is this issue right over here. It's the standard exterior wall, 2x4 studs at 16 inches on center. It's got some sort of stucco layer on the outside, I can see, and probably just like plaster on the inside. These days we'd probably do that stucco on the outside and maybe gypboard on the inside, but we'll kind of model his system. We don't have dimensions. I'm going to guess it's about 3.5 inches wide on the studs. Maybe it might have been a little wider when he built it. On the outside, I'm going to guess about maybe 3/4 for the stucco and maybe about 3/4 for the interior, but it might be a little bit different. There's another sort of base wall case over here, the interior wall condition, and that again would be about 2x4, 3.5 inches wide on the interior, then maybe 3/4 and 3/4 for just plaster on both sides. So we'll create one that looks like that too. Okay. We also have a couple of wall types at the top, and that was part of Schindler's system, was he would have these very standard wall conditions at the bottom and just sort of vary the top. The wall would always be about 6'9" to the top of that first plate. Then there'd be a base plate really for the top wall, sort of be covered with stucco or covered with the plaster too. So I'm going to model a little bit differently. I'm actually going to model the 6'9" plus the continuous top plate. I'm going to model a 6'10.5" inches tall. He's drawing it a little bit differently, but from a modeling standpoint, it'll actually work out better for us to kind of consider that top plate really to be part of the bottom plate of the top part of the wall to be part of the bottom wall. Now, it sounds confusing, but it'll make sense when we actually sort of do it. And then this top part of the wall varies in height. Now, for this top part, it looks like there's about a 2-inch thick, just solid piece of wood, as a lot of the wall condition up there. There's a couple cases over here where he continues just what he calls high plaster. So he has the 2 inches of wood, some blocking, and then the plaster is just trying to match the interior surface of the walls. And then in these clear story cases, he has that big wood piece that he's using as a beam and then just kind of cutting windows in it, either fixed glass windows as clear stories or sash windows if he wants some ventilation in there. So there's really 4 basic wall types: interior, exterior at the lower part, and we'll do this wooden beam at the top as well as a wooden beam that has some plaster in there. So those are the 4 wall types we'll create and then stack them in different ways to kind of create what we need. So switching back to Revit, let's kind of talk about how we can do that. For walls, let's go over to the wall tool, and I can even switch back over to the floor plan view because we're going to draw some in a few minutes. Okay, we will choose the wall tool. We have the standard wall types in here, including these compound wall types up here that actually have multiple layers. And we're going to be sort of creating some compound wall types. We could keep modeling as generic walls, but as we start to get a little more detailed and think about the construction, we'd like to actually consider the layers and how they all interact. So let's go ahead and do that. We can use any of the standard ones. Let me go ahead and I'm going to go for a very simple one. Let me go through and just choose this like, interior 4 7/8 inch partition. It's a 3-layer wall. I sort of understand about, but we're going to change its properties. I'm just using it as a starting point, kind of a template for what we're going to create. Let me go ahead and create that interior wall type first. What I'm going to do is duplicate this. I'm going to call it just sort of an interior, and what is it? It's really 2x4 plus plaster both sides. Okay, it's kind of a good name to sort of describe what it's going to be. The structure is going to be not metal studs. We're going to go for wood framing in the middle. Wood dimensional lumber. There we go. I'll make that. So it's even 3 5/8 here. That's a standard metal stud size. I'll make it 3 1/2 right now. But if we needed to, we could change that dimension to actually match the true lumber that was being used at the time Schindler was working. For the interior and exterior finishes, right now it's set to gypsum wallboard, kind of our more standard finish. Let's see if I can find some plaster. Plaster and lath. Okay, we'll go for that. And choose that. That's going to be, I'm guessing, around like 3/4 of an inch. And again, we'll say plaster and lath down here. Where did it go? Under P for plaster. Make that also 3/4 of an inch. Oops. Okay, we have those. One of the reasons we're sort of choosing these different materials is to get the patterns right, to get the colors right, and also the rendering materials right, and even the quantity takeoff, and understanding how this is constructed. It's good to put the actual materials in there. So let's leave those for right now. We'll say OK to this, and we'll have our basic interior wall. Now our interior wall is going to be complemented by an exterior wall, which is so similar. Let's just edit this type. Let me duplicate it. I'm going to call it exterior. And it's going to be 2x4 plus plaster, I'll say, and stucco. Again, just whatever's going to help you find it in the menu. It doesn't really matter what you call it. But give yourself a nice convenient name. Okay. For this one, actually, we'll be a little more careful. Notice there actually is an exterior side. The top of the list is the exterior side of the wall. The bottom is the interior side. So I'm going to change it up in here. Change that layer to be stucco. And do I have a stucco in there? Let's see if I have an exterior finish stucco. Looks like I don't, or at least I can't find it right away. So let me go ahead and just choose that. I'll duplicate that. I'm going to call that just stucco. Okay. Now we can go ahead and sort of choose a render appearance for stucco. We could, we won't get into that just yet. Let me just choose a kind of a surface pattern for it. Oh, I like my stucco. I tend to put like kind of a sandy pattern to it. A little bit of stippling, a little texture to it so I can spot it. You can give it a color if you want to. The cut pattern. I'll just kind of, I'll just leave it blank for now. It depends on how much detail you want to really have show up in the wall sections. So we can put a cut pattern in there if you want. I'll say OK to that. Now I have my exterior wall, stucco, wood dimensional lumber, plaster, and lath. Say OK. Say OK. And we got 2 of our basic wall types necessary. So let's go ahead and let me pause right there before we create the next ones. Okay, just to let you in on some of my little recording secrets, every time I'm pausing there, what I'm actually doing is saving a little subset of the video, just to make sure we don't lose any of the video along the way. So that's why I keep on saying, let's pause for a minute. But enough of that. Let's get back to actually the lesson. The last 2 different wall types that we want to go through and create for our little samples are, we want to create those top wall conditions. There's a 2-inch thick of wood one, and also one that has wood and a little bit of plaster to kind of level it out with the surface. So let's just create some more wall types. I can just edit this type, and I will duplicate this, and I'll just kind of call it upper. I'll just call it 2 inches of wood. Again, these are just convenient names for you to find them later. We should actually come up with a nice standard hierarchy probably. And what that's going to be is, let's say it doesn't have any stucco on the outside. It just has really structure. I'm going to say it's about 2 inches. And in terms of what it is, it's not dimensional lumber so much. This is more like the finished lumber. And he actually put some nice looking wood that would actually look good in the long run up there. So do we have anything in there? He has wood sherry, wood dimensional lumber. Let me just create a new one. I'll just call it wood finish lumber. And if we go ahead and separate this out, then later on when we're rendering, we can kind of choose the appropriate appearance and it would look good and kind of just appear right in the in all the different views. For the pattern on that one, let's go through, and again, I'm going to give it that kind of swirly, finished lumber look. Say OK to that. It's only about 2 inches thick on that one. That'll be fine. Let me say OK to that. Okay, now for the final one, we're going to actually go ahead and create the one that has the 2 inches of wood plus a little airspace plus a little plaster to kind of match the thickness of the lower walls. So just so you know, what we're trying to match is, oh, where is it? The exterior, let me find it. Right there, the plaster plus the stucco. So the thickness we're trying to match is 5 inches. I have to come up with a 5-inch thick wall. So to do that, what I am going to do is, I'll go back to that 2 inches of wood. Edit this. I'm going to duplicate this. It's 2 inches of wood, okay, plus the plaster. And for that, let's say I don't just want 2 inches, I'm going to give it some finish. And it doesn't really matter for this one whether it's exterior or interior side. Let me insert a couple layers. I'm going to insert a layer way on the outside I'm going to call finish, and that's going to be 3/4 of an inch, 0.75. Okay, and that's going to be the plaster, just so we can match all that. Okay. And then what's going to happen between the plaster and the wood, it's called out as blocking. I could put substrate in there. I could just put an air layer in there. We could call it a lot of different things. Let me just call it an air layer. But it's really mostly air in terms of what's going on in there. And for that one, let's say that it's really the difference. So 2 3/4, I still need to make up the full thickness of the wall. Is it 2 1/4? Let me try that. 2.25. Yep, and I have a 5-inch wall. Okay, and we should be in good shape there. Okay, so hopefully that'll create the basic wall types we need. Okay, now we're in pretty good shape now in terms of what we basically need, but let's stop and think about how we're going to construct this. Because these walls are a little bit different. If I'm placing walls and just the wall heights are all kind of a single material, for even like over here in this case, we just have a single wall that's going to go from 0 up to 6'10½". Okay, that's actually relatively easy. We'll just use one of those existing wall types and give it a height. If I could put a level in at 6'10½", that might be a smart thing to do, or I can just put an unconnected height in there. It just kind of depends on whether we want to have that as an intermediate level. In fact, maybe I should do that. But the other thing we want to do is for these walls that have two different things stacked on top of each other is think about how to model those. And there's actually a really good tool available in Revit for handling that case, where you have two different wall types on top of each other. And that actually happens a lot if you think about it. We have a lot of walls where, there'll be some sort of special brick or stone finish at the bottom of the wall up to the windowsill height, and above that's a stud wall. We have a lot of things where there's like sort of a lower wall condition and an upper wall condition. And in this case, what we have is something where we have a lower wall condition up to 6'10½". And then the upper wall condition will vary in height depending on how tall it needs to be. And that was part of the beauty of Schindler's system, is the bottom wall panels could sort of be pre-manufactured at a standard height, and then the ceiling condition could be changed as necessary to create the architectural feature that he wanted to sort of have in his building. So let's talk about how you do that. What we're going to do is, over in our wall tool, we have all these different wall types that are available in here. Okay. We're going to actually go rolling way on down to the bottom, and you'll find a stacked wall. Okay, and a stacked wall is actually what we want to create, where we go through and create these assemblies. And how we do it is, let's again choose one of the existing ones, and I will just edit it and duplicate it, because I'm going to go through and create two basic stack wall types. I'm going to create one for this exterior condition. Actually, there's really four, the exterior plus the interior. But let's say it's exterior, and I'll say that is, I'll call it the standard plus the wood as one of them. And what I'll do is just basically talk about the structure of that wall. And the structure of the wall looks something like this. There's multiple layers to it. Kind of pull that up in there. The bottom is going to be, let's just kind of call, actually, there's the top of the wall, there's the bottom of the wall. In fact, let me even preview this so you can sort of see. It's a little easier to see. Actually, let me do that slower so you can actually see what I did. There's a preview button which lets us see the vertical profile, and we can kind of take a look at what we're doing here. So what we can do is choose for the bottom wall, I want to have that exterior, and I have to find, the stucco wall. Okay, that's my little wall down there. For the upper wall, what I want to do is have that wood wall, upper wood. Okay, and if I zoom on in over here, you'll notice that, well, they're sort of centering. That's not looking very good. We have a couple things we need to control. We need to think about, really, of these two things, which is the one which is variable and which is the standard height. And the exterior one, the lower wall, is the one that has the standard height. That's the one that I always want to be 6'10½". Okay. And the upper wall is the one that's going to vary. Now, if you have more than two pieces, there's always one that varies. Okay, so you can have as many fixed pieces as you want, and one piece is going to be the one that actually varies. So just kind of remember that. You always have to choose which one's going to vary. And then there's this whole issue of really what the offset is. Okay, and right now it's just the center lines of the wall. Let me go ahead, and what I'm actually going to do is match them up by the finish face exterior, which is the way Schindler actually did it. He lined up that wood with the stucco. You can sort of see it right in there. And that's what you need to do for a stacked wall, is just set up those two different things. So this actually now is a wall that every time I place it, the lower part's always going to be 6'10½". The upper part, just depending upon the height of the wall, will sort of adapt. The wood layer will kind of change to what we need to be. So I'll say OK to that one. That's a great first example. Let me duplicate this. I'm going to do exterior standard plus wood and plaster for the other case. What's that going to look like? It's going to be so similar, except up on the top it's going to be, instead of just wood, it's going to be wood and plaster. It can still be the 6'10½". Looks like that one I actually have reversed a little bit. Let me go ahead and flip that. Finish face exterior interior. What do I have to do here? I'm thinking it's flipped right. That part looks good. Let's say finish face exterior. It's going to fight me a little bit. Let me see if I can put an offset in here. Let me see if this will work. Minus 0.5. Okay, now they're lined up. A little bit of playing to kind of get the geometry just right. I'll say OK to that. For the interior walls, again, very similar. Let me choose this one. I'll dupe this. I'll say interior. Standard wood plus plaster. That one's going to have, as opposed to the exterior, it's going to have our interior wall type here instead. Oops. Choosing the wrong one. Hang on. I rolled when I shouldn't have. Interior, it's not a basic wall. I want to go down to the stacked walls. Check this out. Okay, that's looking good for our interior wall condition. Let's go ahead and, did I do it right? That is right. Nope, hang on, I'm looking at the wrong one. Interior, that's what I want to be looking at. I'm going to rename that, just get rid of that 2 for no good reason, just sort of bothering me. And then finally, we're going to do the final condition. Sorry, this is taking so long. We'll duplicate this. We'll say interior standard plus wood. We'll leave out the plaster layer, and I'll shift that over so the structure is just the upper wood. And now we can decide, which side's which in terms of matching. We'll have to be a little careful as we're placing that to make sure the wood ends up on the right side. It's actually one of the problems with interior walls. It's hard to say which is the interior and the exterior face of an interior wall. Okay, let's say OK to that. We have created all of our standard wall types. I'm sorry that kind of took a little bit to do, but boy, we've set up a lot of infrastructure. Believe it or not, our job is going to be really easy from here on out. So let's go ahead and say OK to that. And we'll save this away. Okay, hopefully you're hanging on after all that setup work. Like so many things, if you do a lot of setup, things get a lot easier in the end, but it takes a while to get there. And that's sort of the same case with these wall systems. So what we're going to do now is, having created these wall systems, just go through and place them. And you're going to find this is actually one of the easier parts of what we're going to do. Let's go ahead and, we'll try creating some of these different details, where if I go back and look at, for example, this area over here, the clear story area, kind of on what's for me the top of the house, we have the standard wall height, 6'10.5" tall, just kind of aligned here. Notice that as we place the wall, though, the stud layer is going to line up with the outside of the concrete and the outside of that subfloor, and that's going to be important as we place it. So let's kind of start with that one. That's probably the easiest case to look at. If I go back over to Revit and I choose that wall type, again, home, choose the wall, and I won't do one of the stacked walls. I'll just do one of the sort of standard walls, exterior. Let's see if I can find that thing again. There it is, plaster and stucco. Okay, what we're going to do is go through and place it. We can give it a high offset. It's currently just at level 1. That's probably fine. In terms of the height, I can send it up to level 2. I can put it in as unconnected if I know it's going to be 6'10.5". I'm just really debating on this one. Maybe I will go through and put something in there, because it is almost such a strong level that I think it might be good to do that. I'll go through and put in a level just at 6'10.5", so that we can work with that. Again, it's sort of a strictly optional sort of thing, but I think it might be a helpful thing to do. Just since in Schindler's houses, he was so strong about doing that. So I'll say this is the bottom of, or what would I call this? This is also almost kind of like the soffit, or what do we want to call this? It's kind of, yeah, I'll call it the soffit level. Okay, and I'll make that 6'10.5". It's just such a common dimension. We're going to keep on using it that it often makes sense to do something parametric as opposed to kind of putting them in there manually and having to change them later. So going back to level 1, I'll again get that wall tool, and instead of saying unconnected, I'll just say just bring it up to the level of the soffit. And that's probably a better modeling technique. We'll come on over here. I'm going to place this wall. In terms of placing this wall, I will choose to sort of pick a line. What I'm going to do is go through and place not the exterior surface. What I'm actually going to do is place the exterior surface of the core being those studs. Okay, that's what I'm actually going to go ahead and place up against that surface. So if I have that line right there, and I place that core, what happens, let me go ahead and show it to you in section. Is we're actually placing the studs right at the face of there. Okay, and that's what I really want to have happen. That's really the matching detail over there. The studs line up, not the actual finished layer of the stucco. Okay, so going through and just placing the exterior one, that's actually pretty good. We can set the heights as necessary. Okay, that one's actually already set to the 6'10.5", hopefully. Let me pop back over. Like my little section, it's not showing up very tall. Let's go ahead and extend it so you can see the top of this. There we can see the top of the wall. That's looking pretty good. So we're pretty good on the height of that one. Let's go ahead and actually just do a little bit sort of more of an interesting thing to it though, and that's to actually think about this issue of, and this is what we all typically do just to lower floor walls. Don't have to do it to upper floor walls, but for lower walls, think about the fact that we typically wrap the stucco down. Okay, why do we do that? We actually like the stucco to wrap over the subfloor layer and even sort of wrap over the concrete a little bit. Now, what Schindler did, actually, we wouldn't do anymore. He actually has the stucco wrapping right down into the ground. And we've learned since then that that's not a great detail. What happens is termites and bugs and moisture wicks up in there, and we have all sorts of problems where the subfloor has rot problems unless we put a lot of flashing in there. But I'll show you what we do typically, which is to actually wrap it down a little bit. We typically wrap it down over this 1.5, that 3 inches, maybe 4 inches, maybe 5 inches. Still holding it a little bit off the ground. We like to have a couple inches there, so maybe I'll just bring it down about 4 inches. So what that would look like in Revit is I'd take this wall, and just for the bottom wall, I'd put a bottom offset on it too. This is going to sound really strange, but I'd put a bottom offset of there of minus like 4 inches. And I will go ahead and say OK to that. It's giving me a bit of a warning. Again, we'll clean that up a little bit later in terms of what the implication of all that overlapping is. But that's kind of what I have in mind. Okay, we'll need to clean that detail up a little bit. Now, this is actually another instance of why it's kind of good to do the level 2. If I'd done the other thing where I said unconnected and left it at 6'10½", what would happen? It'd be 6'10½", but measured from that lower offset. So it would still be a little off right now. So I guess that's another good reason for doing the parametric way. I think I'm glad we did it that way. Okay, do it that way. Now that same sort of thing can happen over on the other side. Let's put that wall in on the other side, which is really more the kind of the two-story, the stacked wall. I shouldn't say two-story, just a stacked wall. Let's choose the wall tool. I'll save that away. And we'll pull down and choose one of our stacked wall types. Let's do the exterior stacked wall, and we'll do standard plus just wood up there. That was kind of what he showed at the other end. I'll come on over here to this side of the house. I'll pick a wall, or pick the lines. What am I going to do? I'm going to place, again, the finish, or the core face exterior, not the finish face, the core face, because I want the studs to line up. And then what should the height be? Oh, this is kind of an interesting one. I think it's going to be, and it's going to be sort of an interesting choice. What do I want to say there? Let me just go to leave it unconnected down, then we'll talk about this in just a minute. I'll put the right thing. Let me go ahead and say that I'm going to put it to the soffit level, but I'm going to put it to the soffit level, say, plus, 18 inches or 24 inches, something like that, 2'0". I'm sort of thinking ahead a little bit to how this is going to work. I'll say apply that, and I'll put that in here. Okay, then let's take a look at that one in section 2. So what's happening over on this side? We again have our issue of the walls looking pretty good. We might go ahead and wrap that down at the bottom, say -4 inches again. And warning us a little bit about all that overlapping geometry. It sort of knows that's something that'll have to be cleaned up later. But notice that, this is sort of interesting. It's a little bit off. I wonder if it's because of the order of operations, because I do want it to be up to level soffit +2. You know, it's kind of an interesting thing. What I should really do for that wall type, if I'm going to go through and sort of include that exterior dropping on down that way, I'll do it for the exterior wall. I won't need to do it for the interior wall, is actually sort of build it into the wall type. That sounds a little strange, but I think it'll work. Let me go say edit the type. So I'm only going to do this for the exterior wall type, where I'm going to drop them that 4 inches. Where I'm going to say the height isn't 6'10½". I'll add the 4 inches in there. So what would that be? That would be 6 foot or 7'2½". I'm sorry, that's a little bit confusing. I'm trying to accomplish sort of two things with a single wall, and I think this will actually work out better for us in the long run. Again, we'll only do it to the exterior walls because the exterior walls need to wrap down, but the interior walls don't. Okay, now I can sort of have the exterior walls come down 4 inches and still have that 6'10½" actually end up at the soffit level. Okay, that's looking pretty good over there. Let's try putting an interior wall in there. Same sort of thing. I'll go back to level 1. For my interior walls, let's go through and I'll choose the wall tool. And I'll say, how about a nice interior stacked wall? We'll just do one that has the wood on it. And I can sort of put it in here, kind of bring it across. Let's also go ahead and put in one that has the interior, the wood, and the plaster. Actually, I should be paying attention to the heights as I put these in. Up to level soffit. Looks like it's still hanging on to that. That part's good. With 2 feet above. So we have a couple of those. Let's take a look at them. So here we have the wood that has only the wood. Let me kind of shade that. Maybe that'll look a little bit easier to see. Okay, here we have the wood. No, I think I liked it better in line. Here we have the wood and we have the plaster. But the nice thing about these stacked walls is, watch this. Yeah, since we have these stacked walls, the bottom side's fixed, we can go through and either stretch it kind of by pulling on it over here, and it'll stretch up the wood. Or I can go through and put in the value here. Oh, I only want it to be 1'4", whatever it is. Okay, and it'll do the nice thing. So the walls are basically going to do the right thing for us, which is great, because in terms of modeling this, it's going to be just an accurate model and sort of stay true to Schindler's house. So here's sort of what it looks like in terms of, we're looking at it in 3D. You can sort of see the idea of the wood on top, and what is it? I guess it's wood on that side, plaster on that side. Notice on the plaster side, let me kind of unshade it there. Okay, it's all heeled up the entire distance, and that's actually the way Schindler wanted it to look. He wanted to have the wood on the top and have the plaster on the side just be continuous as though it's going all the way up to the ceiling cove that way. So we actually have a pretty good model now. It's looking the way it is going to be built, and that's a good starting point for what we need to do next. Okay, let me go ahead and we'll save this little chunk away, and we'll continue with adding some more detail. Okay, now before we go on and look at the doors and the windows and how to put those in the walls, let's look at just a couple more things that are kind of particular little details about like Schindler's walls and how he joins them, especially down at the floor. There's some interesting stuff going on there. You'll see that down at the floor he has some sort of finished floor. I'll guess it's about 1 inch of hardwood, or even down here you'll see he has a detail where it's more linoleum kind of rolled back up under to a little bit of a stucco stop there. Kind of probably in bathrooms and kitchens and places where we want kind of a waterproof surface or a water-resistant surface. But he also has this little funny thing in the corner where it's like a piece of baseboard. It's like the finished floor goes under it, and then there's like this little triangular piece. Let's kind of talk about that. It's kind of in there. It's like 1 by 2, just kind of rolled it at like a 45 degrees, something like that. Okay, that piece right down here, that's a little piece of what I'll call stucco stop. What happens is you don't actually want to run your stucco or your like plaster right on down to the floor. Just as the house moves and settles and things like that, you get cracking in it. So it's better actually to leave a gap or put a little piece of wood in there. Just something so you're not running stucco down to a 90 degree like perpendicular angle. You have a cracking problem later. But let's see if we can go through and model some of these things. So for example, let's come back over and think about the finished floor. This is all the subfloor right now. If I want to go through and put the finished floor in the way that Schindler put the finished floor in, which is sort of between the walls, he actually went through and, again, looking back at his detail, ran the subfloor, or ran the studs all the way down to the subfloor, which is still the way we do it, and then put the finished floor between. That's a more accurate model of how we do this. What we can do is as follows. Let's go through and actually create another floor. And I'll call this, I can just duplicate this one. I'm going to call it just sort of wood finished floor wood, whatever I call it. And this is going to be, let's say that it's only about 0 foot 1 inches. And we could say that instead of wood floor planking, let's say wood flooring. Okay, something a little bit nicer. We can put some, suppose the utilitarian planking, we can go ahead and put some nice finished wood in there. We'll put that in there. That looks fine. Say OK. Now, when you go through and place this, let's talk about how you do that. What you want to do is actually go through and, as opposed to putting it right at level 1, you want to give it the height offset. You're always with floors measuring to the top of the floor. So if we're putting in finished floors as an explicit object, and again, a lot of people don't do this as a separate operation, but if we want to go through and do this, you need to go through and put in that offset. Then I can start drawing the floors. And what would I be drawing the floors to? I could pick the lines or I could pick the walls, either way. If I'm picking the walls, I'm not going to extend into the core. I often say extend into the core, but in this case I just want to go to the finished surface of the wall. So I can go to the finished surface of that wall and maybe the finished surface of this wall, because I really want it to be between, not actually into the wall. Okay, and then I can just sort of draw the boundaries. I'll just put a little bit of finished floor in here. And the reason, again, we don't tend to do this for a lot of houses is if you have to go through and put the floor in on every house in every different room, it gets to be a lot of work to sort of put the finished floors in there. We often use some shortcuts like just painting a floor on or doing some interesting things like that that aren't really very true, but sort of expedient. Let me finish that. Let's take a look at it in our detail now. So that's kind of more what we have in mind. There's the finished floor with the studs and all that kind of stuff, kind of coming on down further than that. You can sort of see the finished floor here is lapping over between the plank floor and the other floor on that side. So yeah, it's kind of not a bad detail in terms of what's going on. Let's take a look back in 3D again. Doesn't look very different. Maybe I should give my finished floor a different color just so you'll recognize it as being different. So I'll go to the materials. And for my flooring, I could choose a different color. I'm just going to shade it for now so you can sort of see the difference. Okay, so we can see where the finished floor is versus the non-finished floor. Okay, the final thing we want to think about is that whole issue of that little baseboard piece. And that's kind of a really interesting thing. It's kind of a nice standard thing you can do. If you put baseboards or crown molding or cornice molding or what do we call it, chair rail in a room, something like that, there's kind of a nice way of doing it. And we do it with a tool called a wall sweep. Let's talk about how a wall sweep works. A wall sweep lets you go through and just basically choose a profile, and we have to choose a profile that we're going to put in here. Let me show you what the cornice one looks like. That's not the one we're going to use, but we could use that as a starting point just to show you. I can sort of choose this wall and put it in there. I'll put it on, actually there's not a wall on that side, so you won't see it over there. You can put it on this wall, whatever height you want it to be. The nice thing about a wall sweep is it does this. If you go back and put a door in, or a window, okay, the wall sweep's actually pretty good about removing itself. So it has the hierarchy of things down right, which is pretty good. That's sort of what we want to have happen to our baseboard. So let me take that door out again, and we'll think about how to create this wall sweep. The deal is for this cornice, which is not the one we want to use, we have this whole issue of it has some sort of profile that it's set to, and we can choose all sorts of different profiles that we want to adjust it to. Okay, so what this is really going to start with is by drawing a profile. You sort of keep on getting that message. I keep on drawing profiles of things. So let me cancel out of that. And I'll go down to my profiles. Let's see if we can go through and just create something that looks like the way we want it to be. Where I'm going to start with that same just dimensional lumber. That was kind of an easy one, and I'm going to save it as something else. Let me just edit this. Okay, which is sort of a start. And what I'm going to do is basically just come up with a profile that has the right shape. Actually, for this, I'm even going to, for editing the profile, I'm going to look at the visibility graphics, turn on the reference planes, just so you can sort of see how this thing is defined. Okay, because this point right here, where those two things intersect, is the insertion point. So I'm not going to be smart about all this dimensioning for what I'm going to do. I'm going to take those out. It's not going to be parametric. I'm just going to draw one just to be quick. That's just static. But what I'm going to do is take out those lines. I'm going to put in some of my own lines. And what do my lines look like? It's sort of what Schindler had shown over here. He wanted something that was kind of a 1x2, kind of flipped over. Okay, so let's kind of approximate that. For me, this is going to be, kind of coming up. I should think about the size of this. Like this. Boy, that looks very funny. Oh, I think it's because there's the dimensions right now. Let's do ourselves a favor. I'm going to go through and I put a line or put some sort of reference plane, something in there so I have some sense of scale, because right now I have no sense of scale. I'll put a reference plane in here. And then what do I want that to be? I'll say if it's a 1x2, maybe that is like, 2 inches off the floor. Okay, at least now I have something to operate on. In fact, we could use reference planes and do something parametric, but again, I'll keep it simple for right now. Okay, so I'm going to do something that is, kind of like this, roll on up, roll on down at 45 degrees, come on over. Maybe I'll bring this one down at 45 degrees. Actually, if I was being smart, I'd sort of say, let's do an offset at 1 inch. Not 10 feet, 0 foot 1. 0 foot 1. That's funny. Which one do you like? 1 inch? Try that. Okay. There it is. And now I can trim those lines up. TR to trim. Okay, that's actually pretty close. Oops, wrong side. Don't do that. Click on the side you want to keep. There we go. Okay, let me save this as. Always save as when you do this. Don't spread over the old one. Let me save this as. And I'm going to say this is going to be my Schindler baseboard profile. Again, we'll use this as a placeholder. Okay, we're almost done with our wall sweep profile. We have to do one very special thing, though, to kind of keep on going with it. And that is every profile actually has a use. And you have to sort of say how it's going to be used to determine where it's going to start showing up in the Revit interface, where it's going to be available as an option. So one last thing to do, though, to adjust this baseboard is this profile that we adapted was for a railing piece, so it shows up there. We have to change this property right over here and say that as opposed to just being a railing, okay, we want to use it as a wall sweep. Otherwise, it's not going to be available for us. And I think that's sort of an important thing as we're doing a lot of these profiles is just pay attention to this notion over here, how it's going to be used, because that'll affect really where it is available. Okay, when we're diffing an existing one, it probably already is set to something that's useful, but in this case, I adapted a handrail to be a baseboard just to get the profile, and I needed to change the application of what that sweep is. So I'll say apply to that. Let me save this away, and I'll go through and load it into our project. Okay, now that we're back in the project, we can go to the wall sweep tool under the home, choose wall sweep. And what we can do is just duplicate this type. Let me duplicate this. I'm going to call it my Schindler baseboard. Okay. Then we'll choose the profile. And we'll choose, if we go moving on down there, I believe it was that one. We can give it a material if I want. For example, let's go ahead and give it like the finished wood or something like that. Did I have any finished wood? I'll just make it cherry for now. That. We can go through and give it a subcategory. I'll just leave it at cornices. Say OK. And now we can go through and place that. And as we go through and place that, let me zoom on in so you can see it being placed. You'll start to see, here's my Schindler baseboard. I can put it right down at the bottom of that wall. I can put it right down at the bottom of this wall, though I should put it on top of the finished floor. Maybe I'll rub this around a little bit and do it that way. And again, choose the wall sweep tool, and I'll put the Schindler baseboard right here. A little too deep, huh? Let me undo that. Come on down. Okay, and once we go through and put it in there, if you need to adjust the height, you can choose it and give it an offset relative to the level. Okay, in this case, it's 1 inch off of the level because we want the base of it to actually be just above the finished floor, as opposed to inserted into the finished floor. And the nice thing again about this this baseboard piece as a sweep is if we go through and put a door in there or something like that, it'll interrupt it. So we actually have the ability to put it in there. So let's leave that there in terms of these finished details, the finished floor details, and move on to the topic of really how we go through and start adjusting the doors and windows so that they look appropriate for the Schindler houses. Now that we've got the floor and the wall assemblies basically set up so we have different types for modeling the house the way we want to, the next step is really to start thinking about putting in doors and windows and what those look like in the Schindler houses. And they're fairly standard. They're not all that different, but he did have some very specific details about how he liked to handle the trim. And what we're going to illustrate now is really how you can customize some of the standard families in Revit to go ahead and start simulating some of the Schindler details. Again, we're going to sort of make a first order approximation here. Later we'll go back and talk about how you can really start customizing these to get exactly or very, very close to what Schindler had in mind. But just as a starting point, let's go ahead and think about, just at a high level, what's different about his doors and windows that we want to try to emulate. So for example, in the door detail, which we're looking at here, he has a little bit different idea of how things should be. He tends to like the idea that doors don't have a lot of trim to them. His doors tended to have, just the stucco rounding around the corners, and they're fairly what I'll call blind. They don't have a lot of trim to them. So if I go back to up here, you can sort of see Oh, on the sides, you can see the edge of the jamb, the door jamb, but there's not trim on the inside or the outside. Although there is this little interior piece at the top. Okay, that's ultimately going to cover that stud, or that top plate, excuse me, at the top. So we're going to leave about 1.5 to 2 inches of trim there. So let's think about how we can go through and try to emulate something like that. It's typically a flat panel door, but a little bit different. So what we're going to do is start with, let me go ahead and save this away. Just the whole idea of a flat panel door, and I can choose one of the existing ones or come up here into the door library and kind of choose that one. But what I'm going to want to do is actually go through and edit the family. Okay, so I have the standard single flush door. What I want to do is just kind of change things. Maybe the best way to do it is to kind of pull it out over here in the project browser and say edit it here, because that'll open up the family so we can edit it. So here's the standard door type. And if we start looking at that door and kind of take a look at how it's defined, you can see, if I even go to the wireframe view, it's defined of a lot of pieces. There's the jamb piece, okay, which is, how is it defined for this door? It might be a sweep. There's the wall itself. That's the wall itself. There's, let's see if I can find it there. I know the trim pieces are just big extrusions that are kind of on the outside. So let's talk about how we can start adjusting those. The idea is that generally Schindler didn't like to have a whole lot of like trim on the sides. He just liked the jamb in there. So what we can do is take these different pieces, okay, which are currently sort of defined, and we can even sort of take a look at how they're defined if I look at the different views and maybe look at the front elevation or the back elevation. You can see there's the extrusion, is the trim width that's defined in there. Okay, and we're going to start ignoring some of those properties, at least in terms of these sides. What we're going to do is actually take this piece right here, this piece of trim, which is the either the interior or the exterior side. I think this is probably the interior side, and we're going to edit it. So I'm going to take that and I'm going to edit the extrusion. And what I'm going to do for my door, as opposed to going through and having all that trim down the sides, is follow Schindler's detail, more like this, where we only have the piece of trim at the top and just the jamb on the sides. So let's take a look at that. What I can do is take this thing and just do a little trimming to it and turn. Let me take, I'll grab this and that. I'll grab this one to that one, just so I can sort of like create I'm only doing just really creating lines for the profile. So I have a little piece of trim at the top right now. I still have to get rid of these pieces on the sides. And those little pieces at the bottom, because I can only have a single loop, or I can need a continuous loop. Let me go and say finish that. Okay, and now I have a little piece of trim at the top. Let's take a look at that in 3D. Maybe just put it back in here in terms of shaded so you can see it. Okay, what else do we need in there? Looks like there's still what's called the model lines, the symbolic representation. We can go ahead and take some of those out though. Well, let me kind of show you where we get to those. Let's take it out there. In here, I can pull that over. What those are all about just basically how things represent in a 2D representation as opposed to a 3D representation. So for these, I just want to take that out and pull that over. Okay, now if you like that for the exterior or the interior, I forget which side this is, let's go ahead and do the same thing on the other side. I will go through and look at the back. Edit it right here again with the extrusion. Again, do the trimming. I'll trim, this to this. I'll trim this to this. That's just to sort of extend those lines up. Then I'll trim in the opposite direction to kind of clean out the ones I don't want. Get rid of this, rid of that. Okay, and I'll finish that up. Okay, and even here, if I shade this, you can sort of hidden line it. You can see we still have those symbolic lines. Those are just lines. And we can sort of move those things over. Actually, I'll just take out these on the side. And this one up here, I'll just move on over. Now, we have something which we think is an awful lot like a Schindler door. Let's go ahead and see if how well it works, though, if we go through and flex it. I can take a look at the properties. Let me take a look at the family types. And the trim thickness right now is currently set to, or the trim width is about 3 inches. I think I want closer to 2 inches. Let me see if I can get that to sort of push on down. It looks like that little top piece of trim did drop on down. That looks pretty good. Let's just try it in terms of different widths. 32 inch. Okay, that's looking pretty good. 34 inch. It's looking pretty good. Okay, we have some different sizes. The final thing is to really think about what is the size of his doors. And as far as I can tell, the size of his doors, he wants them to actually be about 6'9" at the top, which is a little bit strange. Usually they're 6'8", but we'll go for that. So let's go through and create some types, which are Schindler types. And we'll say 36 by, and I can either rename this or dupe it. Let me add a type, which is going to, oops, not a parameter, excuse me. A new type. I'm going to make a 36 by 81 inches, 6'9". Okay, and that'll be 36 by, there it is, 6'9". And I can make some more if I would need to. Maybe like a 32 by 81 also. Again, I'll say a new type. I'll say it's, I didn't do a very good job of putting the dimensions in there, did I? Okay, and that's going to be 32 wide. Okay, now we have a basic Schindler door type. Let's go ahead and say OK to that. Now, don't just save, because saving will go through and overwrite the existing one. I'm going to save this as my, and I'll call this my single flush, but maybe even go ahead and say a Schindler single flush, just because it's part of our Schindler language. Save that away, and I'll load that into the project. And I'll put it into the wall type examples project. Okay, let's see how we can go through and use that. Over here, I have my standard door over there. Let's instead pull down to one of my new improved Schindler doors. And it looks pretty good. In the same sense, though, let's see where that door condition would actually occur. Let's see if we can kind of pop it into one of the exterior walls. I'm going to rotate this around a little bit. So for my Schindler door, let's go ahead and take one of those again. I'll put it into this wall. Okay. And you can see we start to have, I think, the condition that he liked. That's looking a little bit tall in terms of what's going on over there. Why is that looking tall? Let's think about this. I made it 91 inches. I think I want it to be 91 inches. Okay, we've got that door in there. The head height, or the head trim, doesn't look quite right yet. Let's go ahead and take a look at that. If I choose that door, let's see if we can figure this out. I choose the door. There we go. Let me take a look at the properties. The problem here is the trim width for that top is still too big. Let's bring it down to 1.5, which I think will make it match the top. Very good, and that's kind of the detail that Schindler tend to like. Okay, let's go ahead and do something similar. We'll put something like that in the outside wall. Over in here, we'll take that same sort of door. We'll say home door, and we'll put one of those Schindler doors in there, again using the 81-inch tall door. We'll pop it in over here. Okay, and here you can sort of see the detail that he liked, where really the trim right at the top really is just kind of perfectly aligned with just really where that break is between the top of the wall and you know, the wood frame above it, stuff like that. So it's looking pretty good over there. Let's even go through, yeah, there it's looking nicely on that side. Let's flip over to this side. Okay, looking good. So that's a pretty good approximation of the Schindler door, although we'll go ahead and kind of adapt that and make it look a little better even next time. Okay, now that we've customized a Schindler door to kind of be something similar to what he had in mind, let's go ahead and take a look at the windows too. The windows actually have sort of a similar detail to them, where if we go through and take a look at the windows, he has this notion that, again, there's sort of some framing on the side. There's some trim at the top. In fact, that trim often turns into, either some sort of special detail, like a shelf where we can sort of hang like a little curtain valance to hide that, or a little light shelf where we kind of conceal a little bit of light within there. There's a lot of things he does with that piece of trim, or up the top of the window heads. Let's kind of do something very basic right now, which is to just go through and kind of take off the trim on the sides and go ahead and just leave a piece of trim at the top. We can also take a look at the, the window sill. He often projects that, but doesn't have anything projecting on the inside. He likes to kind of roll the, looks like he's rolling just the curtains or the window sill up in there. I think I'm reading that right. That might be the inside versus the outside. But I think, yeah, we'll take a look at that and we can adapt that a little bit more. It's one of the beauties of doing things as these component families is if we make a wrong assumption, we can go ahead and fix it later by just fixing it in the component, and the model will update itself. So let's switch back over to Revit. I'm going to take a look at, let's do the sash window. The sash window being, which one is that? As opposed to the sliding window, it looks like it's one where he's hinging it up. Yeah, it looks like it's got a hinge at the top, as best I can tell. Let's take a look at that. Looks like what's going on there, a hinge sash. That's the head, it's showing the hinge versus on the side. Okay, as opposed, so I think those are flipping up. If they're flipping sideways, we can do it with a casement window, but we'll do it with an awning window instead. As a starting point, let's take a look. So what we'll do is we'll go to the window tool. And we have these fixed windows which are in there right now. We want to load in something a little bit different as a starting point. Let me go through and just go to the windows. See if I can find a nice awning window with some trim. Okay, an awning window being one that hinges at the top. I'll load that in. And again, that's similar to what we want, but not exactly. We're going to do some changes to that. So what I'll do is I'll go down into the families and find it. I'm going to edit that by right-clicking and say Edit the Family. Okay, and it'll come up here. Let me save as just right away this time, just so I don't mistakenly save by accident. It's kind of a good thing to do right at the beginning. I'll call this a Schindler awning with trim. Just so we have that saved as a special type. And I'm going to put it in my own documents as opposed to the main library for right now. Okay, the similar sort of thing as what we did before. If we go through and look at these types, we can choose any different window. There is a trim width to the whole thing right now. If we kind of take a look at the family types, you'll see that, there's a trim projection and a trim width on the interior and the exterior. This is a very kind of well-defined window. I can make that 1.5 and 1.5 if I want to do it on both sides. We'll keep on adjusting that as we need be. Okay, in terms of how far it sticks out or sticks in, that's what the projection is. So just the thickness of the trim in terms of how far it's coming in. Let's just go through and edit the what I'll call the width of the trim, because that's actually sort of the most radical thing that's different about his windows than the other ones. Where we'll again take that, we'll edit the extrusion. And we want to do that. We can even do it in 3D if I want to. I will take that and trim it to this. I'll take this and trim it to that. I will take this long line and trim it to the top, and then I'll take the lower part and trim it to that. Then I can take out the excess pieces. I think I'm getting that right. I'm just going to make sure. It's a little hard to tell in 3D. Actually, it looks like this is a little bit different. So let's go ahead and actually turn on the visibility graphics, and let me turn on all the reference planes so we can see this. I think we're going to have to define this a little bit differently. Let me look at the front placement or the front side view. Take a look. Here's the deal. We want that piece of trim in there, okay, but we want to actually sort of do it a little bit different. What we want to do is, okay, we still want to have the trim width, that's fine, but okay, let me finish taking out the sides. We don't want those. And we can go ahead and get rid of it at the bottom too. We don't want that piece. Okay. So in terms of what's going on here, we do want to go ahead and have that to be a little bit different about how it's coming together, because what we want to do is actually have that trim extend to the outside of the jamb or the rough opening. So what I'm going to do is do a little realignment. I'm going to say align. I'm going to sort of take that line, not the edge of the window, but that line, and lock it to there. And similarly, I'm going to take this line here and lock it to there. Okay, that'll actually get it to extend out the full width of that. In the other direction, we have the whole issue of really, where is that relative to the rough opening? Let me finish that for now. That's probably pretty good. See how that's going. It's always a little bit, what I call risky changing families, but we could always go through and fix things later. Let's see how that looks in terms of that side now. So it looks pretty good in terms of what's happening there. Let's orbit this around a little bit. Let's look at that trim on the side. I got the sash in there. I think that's looking pretty close to what we have in mind. Let's do it on the other side though too, just to be certain. Actually, we should change sizes just to make sure that it's resizing properly. Yep, that's looking pretty good in terms of what we want. Okay. And we will go through and do that on the other side. So if we do that on the interior side, did I do it on the interior or the exterior last time? I always forget. Looks like that's the piece right there. Let's go ahead and edit it. And the same sort of thing. What I'm going to do is do some trimming, where I will trim this to this. Let's see if I got that right. Trim that again, here to here. I think that's going to be okay. I think it's referring to some constraints that just no longer apply. Let me take out these pieces over here. Take out this piece down here and this piece down here. And then finally, I'm going to do that little readjustment. I'm going to align. AL is the tool that gets me that really quickly. From this line over here, I'm going to pull that trim out to there and lock it to there instead. So what I'm doing is moving it. That's why it's complaining a little bit. And again, I'll apologize. This is a little bit, it's a little advanced in terms of what I'm doing. We don't have to get this deep in terms of this first level of modeling, but hopefully this will give us something that's a little bit more accurate. Let me say, let's switch back to the 3D view. Here it is on that side. There it is on that side. Let's just kind of switch to a different family size. Okay, that's looking pretty good on that side. And it's looking pretty good on that side. Okay, so I think we have something that's pretty close right now. Let me save that away. And we will load that into the project. So what do we do with our Schindler window now that we have it in there? Let's go on over to, we can put it in one of the 3D views or in one of the 2D views, either way. Let me kind of rotate this around. And it'll put it into that exterior wall. This is that whole thing, depending on which side the sill is supposed to be on, whether it's on the inside or the outside, whatever's supposed to happen in there. We can flip this window if we want to. I will choose it, and I can say flip the facing. Okay, and that'll kind of rotate it around that way. Oh, there's a little bit of trim around it. In terms of the height, let's kind of adjust some of these things. We know the height is supposed to be, what did we decide? It was like 6'10.5" for the head height. And then if the trim condition's there, we could edit that trim. And instead of being, trim width of 3.5, we actually want it to be about 1.5. So we should basically change our sizes to kind of match what we need to. And that's a little bit closer to what we have in mind. So that's actually not looking too bad right now. So we're going to want to do that to a couple different window types. We'll want to do that same sort of basic operation for the, what was this? This was the awning window, the sash window. We'd want to do the same thing for a sliding window, as well as to a couple of different fixed windows. And I won't show you all that in the video. I'll go ahead and kind of create a couple and put it into the the example data set just so you sort of have those available to kind of work with. But you can imagine sort of doing a very similar thing where we load a standard family, and what we're going to do is just sort of edit the trim all around it to only leave that top piece and adjust the thickness of that trim. So I'll pause the video right now, create a couple of those, then we'll jump back in with some of the final things we want to show you. Okay, we're returning after a brief break, and what I've done in the interim is actually created a couple more types for you. So there's a awning with trim, a fixed with a trim, and now a slider with trim, and they're all going to be available out there on the Dropbox for you to play with. So go ahead and take those. They're just windows that sort of different conditions of basically doing the same thing where I've adapted them to just to use the you have the different trim condition that Schindler preferred. So if we go through and choose the window, and I, for example, put the slider in with trim, let's just kind of put some big old size in there. The Schindler slider with trim, like a gigantic one like this, I'll put it in. We'll take its head height, and again, the head height is going to go ahead and match that. What did I say? It was 6'10½". Okay, and then we need to adjust the trim height itself, and that trim is going to be 1.5. And again, these are all just sort of placeholders for now. We'll learn how to sort of get even more accurate to the true Schindler details as we kind of keep on going. Okay, so there's a couple of conditions we want to talk about in terms of placing them. We've been looking at the standard exterior wall conditions, and we want to take a look at, just as a special case, is that transom condition. So let's take a look at it in the detail just to refresh ourselves. And in the detail, what happens here is we have the lower wall, but we have the upper wall kind of starting at the 6 foot, what did we decide it was? At the 6'10½", and continuing up to whatever height that's going to be, with a little window inserted in there where he's actually using that upper wall as a beam to go ahead and support the roof in that transom condition. So let's go ahead and create one of those just so we can sort of see what that looks like too, so you can include it in your language. For the transom condition, we'll go ahead and do one out over here where we have this lower wall at that, at that level, just kind of down at the first floor level, where we'll put the upper wall in above it. So let me go to the floor plan view. It's going to happen up here on this side. We're going to put it in another wall. And this is just going to be the upper wall as opposed to the lower one, the one that's actually going to serve as a beam too. So let me choose an upper 2-inch wood. Okay, if we don't have the plaster condition too. In terms of the base of that, the base offset is, we could actually go through and put it at the soffit level. And let me make sure I got that right in terms of, as I remember properly, it is 6'10½". Perfect. So we can go through and put that in at the soffit level. Okay, and how high is it going to continue? It's just really however high it needs to be, whether it's level 2 or unconnected a certain distance, whatever it's going to be in terms of how high you had it. We'll go through and put one of those in a certain distance back to sort of form the clear story. Now here's the hard part. You're not going to see it because we're in the floor plan level and it's above our head right now. If I move the cutting plane, I'd see it. This is that kind of common thing where you get the warning, or if I did it in the ceiling framing plan, you'd see it there, or the ceiling plan, you'd see it there. Let's just take a look at it in 3D. There it is, and I can look at it in section 2 and sort of understand it. And for putting the window in there, what are we going to do with the window? It looks like the windows he's typically put in there at, what was he leaving? He was always leaving about 6 inches to the bottom of the window. So we can do that same thing. Let me go through and grab some sort of window. And this window is going to be a fixed window. It could be an awning window. It just kind of depends. He has both conditions at different points. Let me grab a fixed window. There we go. Not a very tall one, like a 24 or like a 16-inch tall one, something like that. And we'll go ahead and just place it right into here. It's hanging out a little bit right now. That's not very good looking. Oh, actually I have the wrong dimension. It's like 16 by 48 tall. Let's go ahead and kind of switch that around. I really want it more duplicated. I want it to be like 48 by 16. So I'll say 1'4" by 4 feet wide over there. Okay. We can also say really what the height is, the level off of that, and if I want it to be 6 inches, that's where I put it in. Based on the level soffit, it's 6 inches above that. Okay, this one probably has a lot more sill than it needs to, because I think his little awning windows didn't have nearly as much sill. So sill height, trim projection. I might need to go through and add that in as a parameter so I can go ahead and adjust that, or take it out in the family so I can do what I need to. Okay, but I have that sort of basic condition now. Then to sort of understand what's going on, let's go back to, well, what do I want to do? Let's look at the section, see if I can see it there. So I can almost see it right there. There's basically the awning window. The section's cut a little bit out, but there's the clear story. What we're going to do later is add the roof in and the roof in here with a soffit to go ahead and match his condition, which is these pieces right here, this plank roof with a little bit of fascia on it, to go ahead and complete that. But we'll save that one for next time. Okay, now to complete our treatment for today of the Schindler wall types, let's take a look at one other type that wasn't the Schindler frame but was used at the King's Road house, because it's kind of important you understand how that one was created too. And it uses a very different methodology. It uses, rather than kind of this long continuous frame wall, the notion of a big old precast or a cast concrete wall, a reinforced concrete wall. I think Mary Lou was saying that they were actually sort of poured in place and tilted up, kind of right there on site. But just to sort of understand, it's kind of an unusual wall, and it's got a kind of a sloping surface. It's 8 inches deep at the bottom. I'm not sure how many inches it is at the top, probably only 2 or 3 inches at the top. It's got a flat surface and a sloping surface. It's got that little kind of keyway down at the bottom, that little kicker to kind of hold it in place in that foundation we looked at the other week. Okay, and it's a component wall, so it's actually something where it was made in panelized pieces. I don't know if they were 8 feet long or 10 feet long, but it was made in individual pieces. And we could create those too, but we're going to create those as a component, as really, kind of a wall piece. So let's kind of talk about how we can go through and do that, because it's a little bit tricky. It's a little bit different than the type of walls that we typically do. What I'm going to do is go back over to Revit, and we will not pay attention to the foundation right now, but let's think about how you can create a wall as a piece. And we could do it, I'm going to shift from doing an in-place piece, which is something that would only be used in this project, to something that would be a little more generic, like as a wall panel component, and see if we can create something. What I'm going to do is actually create a new family. Okay, that's how we create components. And we'll take a look at the different types of families we can create here. Oh, do we have like a wall piece? I don't have a wall piece in there, so I'm just going to have to go ahead and use a generic one for now, because walls are a little bit different. Well, think about that. Or we could call it a piece of structural framing. Even that's a little bit different. Let me just call it a generic piece right now. I'll think about whether there's a better way to kind of like think about that later. But we'll call it a generic model for right now, and I might have to kind of mess around with that a little bit later. Okay, but in terms of that generic model, let's go ahead and open that up as a template and kind of think what's going on. We got sort of basically a floor plan view here right now. We could also go ahead and shift to more of an elevation view. And what you're looking at here, these are called reference planes. And these reference planes are all about kind of placing components. So if we look at it from the top, there's a left and a right and a front to back one. There's also kind of an elevation one over in here. And if we look at it in the elevation view, that's again sort of either left to right or front to back, and there's the base level for it. And that all sounds kind of a little bit mucky. We'll talk about some more about this, but let me give you kind of the real quickie about how you might do something like this. Okay, what you need to do is basically sketch a profile, kind of like what we've been doing in all these other different things. So I can sketch a profile that will be extruded, okay, and that's basically what we're going to try and do. We'll say home. I'm going to make an extrusion, and I'm going to basically sketch the profile of that wall. And that wall is, for the most part, it's pretty flat as a surface, and it looked like it went up about 8'8". It kicked over a few inches. Okay. Down at the bottom, it looks like it came out about 8 inches, I think is what he was calling out. Okay, and then it sloped up, and there was some surface slope to it. Okay, and that's pretty close to what we need. Let's go back and take a look at that. It's not quite the same. It's got a little kind of little detail at the bottom there where it comes in. It also has this little notch out the bottom here. So let's kind of take a look at those two things too. What I'm going to do is go back over to Revit, and I'll adapt my profile just a little bit and say that let me just kind of allow a little space for that notch as a starting point. And then I'll do some trimming because, like most of the pink line rules, I have to have just a surface, a continuous loop, excuse me, and I can finish that up. Okay, now, so far that's just sort of a little like a 1 foot piece of kind of a 3D wall. Okay, and that's actually not too bad as a starting point. We can go ahead and take this and give it a material like cast in place concrete or whatever we want to make it. I'll just call it the default wall for now, but we can kind of give it something a little bit different as we get a little more custom with this. We'll talk more about that too later. Let's go ahead and give this a little bit of a variable length, because here's the deal. As we go through as an extrusion, it only is currently set to be 1 foot. And 1 foot is okay, but if we'd like to have something that's a little bit more resizable, what we can do is this. Let me go ahead and shift over to either the front or the front or the back. I guess let me do left or right because I want to look at it kind of more the length of it. Here's the deal. This is going to be the placement location at the reference level and that point. If I'd like to kind of make this thing a little bit stretchable, and again, this is getting to sort of advanced stuff, what I'll do is I'll put a reference plane in. Okay. And what I'm going to do is actually put a dimension to that reference plane, because this reference plane is going to be used for stretching the geometry, where I can put a dimension in from here to here. And if I'd like that to actually be a parametric dimension, something that I can use to stretch the wall, what I do is I add a label to it. I add a parameter to it. I'm going to call it the wall panel length. And we can either make it a type parameter, that would be we'd have different types that all have links to them, or I can adjust it individually. Right now, let me go ahead and do it as a type parameter, because I think he did it that way. He had like typically 8-foot panels or 10-foot panels as groups, as opposed to making everyone a custom length. What that does for us is, if we have that, okay, we can go through and make a family. Let me go through and make one that's sort of 8 feet long here. See if it stretches that. It looks like it's stretched the way we want to. I'm going to call this basically my 8-foot panel. Let me go ahead and create another new family type. I'm going to call it a 6-foot panel. And I'll make that 6 foot for that one. Okay, so now I can switch around between my 8 foot and my 6 foot. Okay, and it's moving that line. So far, so good, but it's actually not moving the geometry yet. What I need to do is just take that geometry, and I can either drag it or I'm going to use the align tool to lock it in. I'm going to take that line and the edge of that wall and lock them together. So what does that accomplish for us? That basically is taking this wall panel, and now as we go through and look at the different types, I can move to the 8-foot panel, make it longer, the 6-foot panel, or if I actually needed a 2-foot panel, I could do that, just whatever it is that you need. Set the dimensions for that one. Okay, and that's my 2-foot panel now. So I can place panels and choose different sizes. Okay, that's looking pretty good in terms of what's going on. The last little thing that I want to do, let me go ahead and save that, because that actually looks like a pretty good little piece of work. Let me go ahead and save that to family. I'm going to call this my Schindler, my Kings Road wall panel. Precast. Okay, I'd like to also go ahead and kind of put that little, that kicker thing down at the bottom there, so we can kind of put it into our notch. Again, it's this little thing. So let's go through and model that thing in here too. I can model as a separate piece, but if it's always going to be here together with the wall panel, I can just model it right in here too. And let's see how we can do that. We have this one extrusion here, okay, and that's the extrusion for the wall. I can create another extrusion, kind of another little piece of it, which will be that little kicker. And for that, what will I do? I'm just going to trace this edge. Come down about 45 degrees. haven't been paying very careful attention to the dimensions, so we'll want to go ahead and fix that. But, oops, and I think that thing's going to fit down in a notch. I think it has that squared out. Let's go back over there and take a look. Yeah, it's kind of square, then it just dives down when it hits the floor. Okay, so more like this. Again, I'm being a little sloppy right now, just so in the interest of kind of getting this done quickly. But we can go ahead and get this fixed up and make it right. Let me trim this to trim those two. Okay, and I've got an extrusion there. Let me go ahead and sort of do that. Again, it's sort of a small extrusion. If I switch over to one of the other areas where I can see it, what I can do is do that same sort of locking. I'm going to align this to that, lock it in place. Okay, now what's going to happen is in my 3D view, that little piece is going to move with the other piece. So as I go through and change between the different types, you know, I get 4 foot and 8 foot, whatever, it'll always change in there. So we're looking pretty good. Okay, one other thing I may want to do this thing is really just go ahead and control whether it turns on. You'll see there's this whole notion of, and this is kind of getting into really kind of an advanced concept, but you can have families that have different little pieces to them. And if I want to sometimes have that here and sometimes I don't want to have that here, let's go ahead and kind of set up a variable that'll let us do that. What we can do is if I choose that thing, one of the things you can do for any individual piece is decide whether or not it's visible. And I can turn that on and off. It's going to still look visible just because it has to show it to me in the family so I can even know that it's there. But what I can do is set up a parameter that'll let us control that. And to do that, right next to the visibility, there's a little button here. If you click that, it'll let you basically add a parameter. And this will be like a yes-no parameter because the issue of visibility is really yes or no. And I can say whether I really want it to have the kicker visible or not. I'm going to actually let that just be controllable on a wall-by-wall basis so we can turn it off or off. That'll make it turn it on or off independently. That'll be an instance parameter. Say OK. And what's going to happen now is for every individual instance, we'll have the ability to kind of turn that on or off, kicker visible. And then we can sort of adjust it back in the project about whether we want that. So let me save this away, and we'll just show you how you'd use this. I'll load it back into that same project, even though it doesn't have the right foundation, just to kind of show you what this would look like. Okay, so here I am. I basically now have in my generic objects, which are down in here, my Schindler wall panel of different sizes. And I can drag it out or kind of place it whichever way I want to. Let me take an 8-foot panel, and I'll just sort of put it into the project just so you can sort of see it. Put it over there for right now. Okay, there it is. It has parameters, so we can go through and choose which size, 6 foot, 2 foot, whatever it is we want. Okay, let's go ahead and take a look at it in 3D. There's that wall panel. Looks like it has, I have it reversed. Let me kind of rotate it 180 degrees, get it into place. Okay, and there it is. If I want to actually start controlling it now in terms of the whole issue of kicker visible or not, I can turn it on or off and either have a kicker on that wall or not have a kicker on that wall. Okay, and again, I know a lot of stuff just happened in the creation of that little component wall. Let me take this, I'll make it the bigger one, like the 8-foot panel. But you can, I hope you can start to see how you could use those wall panels to also go ahead and create a wall that's just made out of a panelized construction. And we'll talk a lot more about kind of customizing families and how we start really getting some control over that when we're there next week. But hopefully this will get you enough to get started with that. So if you're the Kings Roads folks, you can start thinking about your walls that have that kind of custom slope and that kind of funny toe condition with them too. Okay, so hopefully that'll make sense and this will get you started with things. I'll put all these files up in the Dropbox and the video for you and get started with all that stuff, and we'll just pick this all up next week when we're actually visiting you in person. Okay, you guys take care. Bye-bye.